Chapter 3 discusses the interdependence and gains from trade. First, interdependence. One of the 10 principles mentioned in Chapter 1 is trade can make everyone better off. This is when we start to explore what exactly that means. So we now learn why people and nations choose to be interdependent and how they can gain from trade. The lessons illustrated by this international trade example given above also apply to trade between two individual producers. But let's first look at two countries, the U.S. and Japan, and two goods, computers and wheat, and one resource, labor, measured in hours. So this is a bit of a continuation of our example from the previous slide lecture. We'll look at how much of both goods each country produces and consumes, and if the country chooses to be self-sufficient, what happens, and if it trades with another country, what happens. So again, this example illustrates international trade. Could also be an example of trade between two individual producers. We're going to use two countries in this example, but note in the chapter in the textbook, it does the reverse. It develops the lessons in the context of an example involving two individual producers, and then states that the lessons also apply to international trade. So between this PowerPoint and the textbook chapter, you will see the same concepts and lessons developed in two different but entirely consistent approaches and examples. The example here is highly contrived and unrealistic in order to illustrate a complex concepts as simply as possible. This example has some qualities that make it especially valuable. Namely, the two goods are fundamentally different. We're talking about wheat and computer here. So one is agriculture and the other one is manufacturing. This makes the gains from trade based on comparative advantage very likely, given they're two very different goods. There's much more likely that the U.S. needs to concentrate in one and Japan concentrate in the other. An example using more similar goods, say laptop computers and MP3 players, wouldn't be appropriate for this chapter because it would more likely give rise to inter-industry trade and open up all kinds of questions. The gains would likely arise from a source other than comparative advantage, probably increasing returns of scale. Long story short, we're using a very simple example of wheat and computers that are very different. In the example here, it turns out that the U.S. has an absolute advantage in both goods. We're going to talk about what an absolute advantage is, yet both countries gain from trade. So just because the U.S. has an absolute advantage in producing both wheat and computers, it doesn't mean it should produce those self-sufficiently. You will see, therefore, that a comparative advantage, which is another concept we're going to address in this chapter, not absolute advantage, is what's necessary for trade to be mutually beneficial. In the real world, one often sees gains from trade based on comparative advantage occurring between countries that are very different, such as trade between rich industrialized countries and poor developing countries, very different countries. This example shows trade based on comparative advantage can also occur between countries that are of similar levels of industrialization and income. Of course, the U.S. and Japan are very different culturally in terms of size, but they are far more similar in terms of income level and status among, say, comparing the U.S. to, say, a poor country like Botswana. So that kind of sets the table for the entire chapter. The production possibilities in the U.S., in this example, we're going to say the U.S. has 50,000 hours of labor available for production per month. Producing one computer requires 100 hours of labor, and producing 1 ton of wheat requires 10 hours of labor. So that's a continuation of our Chapter 2 PowerPoint slides. In a few moments, we're going to actually derive Japan's production possibilities frontier, excuse me, and they will need to follow, you guys will follow the same steps to show how we derive the PPF. So here is the U.S. PPF. The U.S. has enough labor to produce 500 computers if it concentrated in just computers, or 5,000 tons of wheat, or any combination along the production's possibilities line here. So any combination here. They can do all computers and produce 500, or all wheat and do 5,000 tons. So again, the U.S. has 50,000 labor hours. It takes 100 hours to produce a computer. If the U.S. uses all of its labor to produce computers, then it'll produce 50,000 divided by 100 is 500 computers. Hence, the horizontal intercept is 500 computers, where it's also 0 wheat. It takes 10 hours to produce a ton of wheat. If the U.S. uses all of its labor to produce wheat, then it will produce 50,000 hours divided by those 10 hours is 5,000 tons of wheat. Hence, the vertical intercept is 0 computers and 5,000 tons of wheat. So in this example, the PPF is a straight line that connects on the two endpoints. The U.S. without trade, if they decided not to trade, suppose the U.S. uses half of its labor to produce each of the two goods, then it will produce and consume 250 computers and 2,500 tons of wheat. They're splitting it down the middle, their labor, that is, and that's what they would produce if they used a half and half. Of course, the U.S. could choose a different path. The actual choice will depend on the preferences of society. In the following chapter on supply and demand, the next chapter, we will learn what determines how much of each good society produces. It's important to note that without trade, a country just consumes what it produces. So there's less choices, maybe less availability as well. So now let's derive Japan's production possibilities frontier using the following information. Japan has 30,000 hours of labor available for production per month, so they're in a little different situation than the U.S. Producing one computer requires 125 hours of labor, and producing 1 ton of wheat requires 25 hours of labor. So the hours are different. The hours to produce a computer and the hours to produce a ton of wheat is different than from the U.S. The graph we're gonna complete here will measure the computers on the horizontal axis. Now, if you want on your own, I would encourage you to go through, get out a piece of paper, and go through and derive using a calculator or long division if you can do that in your head. And you can print out my slide notes and derive this on your own. It'd be good practice for the test. So we have wheat in tons and computers and units here. Japan has enough labor to produce 240 computers or 1,200 tons of wheat, or any combination along the PPF. So if they produced all computers, it'd be 240. If they produced all wheat, it'd be 1,200. Now, how we got this number here, looking at the horizontal first. Remember, they had 30,000 labor hours to give, and it took 125 hours per computer. So you divided the 30,000 labor hours by the number of hours it takes to produce a computer, and if they produce all computers, they produce 240 computers. Now, conversely, if they wanted to do all wheat, you look at the vertical intercept here. Again, they have 30,000 labor hours to give. It takes 25 labor hours to produce a ton of wheat. So you take 30,000 divided by 25, and you get 1,200 tons of wheat. So if they did all wheat, it would be their maximum output for wheat with 0 computers would be 1,200 tons. So again, if you want to go back to the previous slide and pause and then do those calculations just so you make sure you have them straight, that would be a good idea in preparation for the test. So let's look at Japan without trade. Suppose Japan splits its labor in half to produce each good. Then it would produce and consume 120 computers and 600 tons of wheat. So again, going back here, 240 computers max, 1,200 tons of wheat. Cut that in half with labor hours. You have 120 computers and 600 tons of wheat. So let's look at consumption with and without trade. Without trade, if the U.S. just consumes what it produces and splits it evenly, the consumers get 250 computers and 2,500 tons of wheat. If the Japanese do the same thing, the consumers get 120 computers and 600 tons of wheat if they just divide things evenly and do not trade. Now, we'll compare consumption without trade to the consumption with trade. First, we need to see how much of each good is produced and traded between the two countries. So, again, I would encourage you to take some moments before we switch to the next slide. If you want to pause it and try to address these questions here, and then you can come back and compare your notes to what we're about to discuss. But we're going to address the following questions. Suppose the U.S. produces 3,400 tons of wheat. How many computers would the U.S. be able to produce with its remaining labor? So you have to figure out how much labor it takes to produce 3,400 tons of wheat, and how much labor is left over to produce computers, and then divide that by the hours that you have remaining, and tell how many computers it can produce. So draw the point representing this combination of computers and wheat on the production possibilities frontier. That's very likely could be something you have to do on the test. Now with the Japanese example, suppose Japan produces 240 computers. How many tons of wheat would Japan be able to produce with this remaining labor? Now remember what the maximum was for Japan, and then that can tell you how much you got left, how much labor you've got left over to produce wheat. So you can draw that on a PPF as well for Japan. So if you want to pause here, I can give you a few minutes to solve these problems before showing you the answers on the next slides, but the answers are coming up. If it helps you work it through, we're going to move on to that right now. So the U.S. production with trade, producing 3,400 tons of wheat, like the question states, requires 34,000 labor hours. That leaves a remaining 16,000 labor hours that are used to produce 160 computers. The red dot represents the combination of 160 computers and 3,400 tons of wheat. So 160 computers and 3,400 tons of wheat. We will assume that this is the combination the U.S. produces in the scenario in which the U.S. trades. So they decided to produce 3,400 tons of wheat in our given example. That leaves 160 computers to be produced. Now, Japan with trade. Again, from the question, we know that they are producing 240 computers, which requires all of Japan's 30,000 labor hours. So Japan would produce 0 tons of wheat. The red dot, again, represents the combination of 240 computers and 0 tons of wheat. We'll assume this is the combination in trade that Japan produces. Just because Japan is not producing any wheat does not mean that the Japanese consumers must all go on the Atkins diet. If you know what the Atkins diet is, it shuns bread and other foods made from wheat. When trade is allowed, Japan can trade some of its computers for wheat produced in another country. Not directly, that would be bartering. However, they can sell computers for cash to people in the U.S., and they use that cash, exchange it, and buy flour and bread and things made of wheat. So this leads to exports and imports. These terms are very simple. Exports are goods produced domestically and sold abroad. Imports are goods produced abroad and sold domestically. There's some subtleties here, though. Someone, say, from Germany or South Korea visits Las Vegas and spends $200 on a pair of tickets for a show. How should we classify this and other expenditures by foreign tourists who are lodging and using lodging and entertainment while they're vacationing here? Well, even though they're consuming it in Las Vegas, Nevada, or actually I had somebody from Oregon at my previous school tell me it's Nevada. Anyway, we count it as U.S. exports. It doesn't matter that the service was consumed here. What matters is that it was produced here but sold to a foreign buyer. So it can be a little more tricky than you think. Hence, a more precise definition of exports would be goods and services produced here and purchased by foreign buyers. This stricter definition of exports doesn't care whether a good or service was consumed in the buyer's home country or in the exporting country. A stricter or more precise definition of imports as well would include the purchases by domestic residents of goods and services produced abroad. So including entertainment, lodging services that, say, tourists from the U.S. use in foreign countries they visit. So you take a trip to France. That's an import. You're there, but you're importing part of their tourism. So it's a little more intricate than the one sentence definitions you see here. But just keep in mind, think about the buyer who's buying, and that'll help you tell whether it's an export or an import. So looking at our third little problem set here, suppose the U.S. exports 700 tons of wheat to Japan. Okay, so they start trading and imports 110 computers from Japan. So Japan imports 700 tons of wheat and exports 110 computers. So depending on where you're looking at it as a U.S., you can be an exporter or an importer. Or if you're looking from Japan, you're importing the wheat, not exporting it. And you're exporting the computers and not importing it. How much of each good is consumed in the U.S.? So we can plot this combination on the production's possibilities frontier. How much of each good is consumed in Japan? We can also plot that on the PPF. We can also do it in table form. We're going to look at both here. Again, the red point represents production. The trade untethers consumption from production. Okay, so this is pure consumption, import, export. The light blue point represents consumption. Notice that the consumption point, the blue point, is above the PPF. Without trade, it would not be possible to consume this combination of two goods. So that's a gain from trade right there. You're getting something you otherwise would not be able to do if the U.S. didn't trade with Japan. So it benefits you as the consumer. In a sense, international trade is like technological progress. It allows society to produce quantities of goods, produce and consume quantities of goods that are otherwise not possible. So if you remember in the previous slide set, to get to this blue point, we would have to shift this PPF outward, and only a technological or development or the availability of more labor would do that. But trade can allow that. So again, U.S. consumption with trade, we produce 3,400 tons of wheat and 160 computers. We import 110 more computers. We don't import any more wheat because we get a lot of it. We send some of it out, 700 tons of wheat. Turns out we got more computers than we produced, and we still got a ton of wheat. We just sold some to Japan. Now looking at Japan, again, the light blue point representing consumption is above PPF. Without trade, it would not be possible to consume this combination of goods. They're producing all computers, 240, zero wheat. Yet, they're not on that Atkins diet. They want some wheat, so they import it from the U.S. And then they export some computers. Make a little money, spend a little money here. So the amount that they consume then is the difference. Okay, 240 minus 110 that they send away. They still have 130 computers. And they bring in some wheat with that trade. So trade makes both countries better off. Let's take a look at it in table form. So we look at consumption without trade, U.S. and Japan. Consumption with trade, U.S. and Japan. The consumption without trade, the U.S. is going to have 250 computers and 2,500 tons of wheat. But with trade, look at this. We produced, 3,400 tons of wheat, but sent 700 away. And then we also got more computers. So we have more computers and more wheat. The gains from trade, plus 20 on computers and plus 200 tons of wheat. Okay. Now Japan, consumption without trade, 120 computers and 600 tons of wheat. Remember, this is when we split the labor right down the middle and did half and half. Now we decide to do some trade. All of a sudden, Japanese consumers have 130 computers to choose from and 700 tons of wheat. So by trading, the gains from trade for Japan were 10 more computers and 100 more tons of wheat. So both are made better off. So where do these gains come from? Well, this is when we talk about the two advantages we can talk about in international trade: absolute advantage and comparative advantage. The first one is absolute advantage. This is the ability to produce a good using fewer inputs than another producer. So you can put in fewer labor hours and produce more wheat in computers. The U.S. has an absolute advantage in wheat. Producing a ton of wheat uses 10 labor hours, so that's less input, versus 25 labor hours in Japan. If each country has an absolute advantage in one good and specializes in that good, then both countries can gain from trade. So you want to really go with what you do best. Okay. The last bullet point states that gains from trade will arise if each country has an absolute advantage in something. But what we'll see next, though, is that absolute advantage is not required for both countries to gain from trade. Which country has an absolute advantage in computers? Producing one computer requires 125 labor hours in Japan, but only 100 in the U.S. So remember, the U.S. can produce wheat better and apparently can produce computers better as well. So that means the U.S. has an absolute advantage in both goods. So why does Japan decide to specialize in computers? Well, we saw in the previous graph that we're going to have a better gain from trade by doing so. But why do both countries gain from trade when the U.S. has an absolute advantage in both? Well, we're going to introduce here in a second something called comparative advantage, but some common sense might tell you, well, Japan is an island nation. Do you see a lot of fields for growing wheat? Well, that's probably why it's much more expensive to grow wheat in an island nation. This is an aerial shot of a Japanese island. Also, Japan's got this guy stomping around. That could really mess with some wheat crops as well. But seriously, two measures of the cost of a good. Two countries can gain from trade when each specializes in the good it produces at the lowest cost. Absolute advantage measures the cost of a good in terms of the inputs required to produce it. So simply, you can use less inputs to produce a good like computers or wheat. And if you're the one with the lower input cost, you have an absolute advantage. Now, we saw that the U.S. has an absolute advantage in both products in this example. Now, recall, another measure of cost is opportunity cost. In our example, the opportunity cost of a computer is the amount of wheat that could be produced using the labor needed to produce one computer. Okay? So now we're changing things up. We're not looking at absolute advantages. We're looking at something called comparative advantage. How opportunity cost and comparative advantage relate? Comparative advantage, again, is the ability to produce a good at a lower opportunity cost than another producer. Okay, so not just on a lower absolute cost, but a lower opportunity cost. Now, as you begin to more and more think like an economist, you're going to think more in terms of opportunity cost. Which country has a comparative advantage in computers? To answer this, we must determine the opportunity cost of a computer in each country. Again, thinking opportunity cost, not input cost here. The opportunity cost of a computer is 10 tons of wheat in the U.S. Remember, the U.S. can really produce some wheat. So when you cease producing wheat to produce computers, you give up more wheat. Producing one computer requires 100 labor hours, which instead could produce 10 tons of wheat. In Japan, the opportunity cost of producing a computer is only 5 tons of wheat. Producing one computer requires 125 labor hours, which instead could be used to produce 5 tons of wheat. So the trade-offs are different. So Japan has a comparative advantage in computers. What's the lesson here? Absolute advantage is not necessary for comparative advantage. Why? Because comparative advantage is not looking at absolute cost, but also opportunity cost. What is the U.S. giving up to produce computers? They're giving up a higher volume of wheat production to produce computers than Japan is. Japan can produce computers at a lower opportunity cost, so they have a comparative advantage. Comparative advantage in trade. Gains from trade arise from comparative advantages. There's differences in opportunity costs. When each country specializes in the goods in which it has a comparative advantage, total production in all countries is higher. The world's economic pie, if you will, is bigger and countries can gain from trade. Now think back to that table where with trade, both countries were better off. The same applies to individual producers, like in the book where they talk about Farmer Frank and Rancher Rose, who benefit by specializing in different goods and trading with each other. Now you know why I encourage you to go through the lecture and the reading, because you got two different examples going through the same process. So here's some unanswered questions. We made a lot of assumptions about what the quantities of each good that a country produces and the trades and consumes, what it produces, trades, and consumes. We made a lot of assumptions there. And and the price at which the countries trade wheat for computers. In the real world, these quantities and prices will be determined by the preferences of consumers and the amount of technology present and the resources in both countries, like the lack of open land in Japan. We will begin to study these concepts in the next chapter. For now, though, our goal was to merely see how trade can make everyone better off, and I think we've illustrated that. The textbook has a brief explanation of the range of prices in this chapter that permits gains from trade in the context of the farmer-rancher example. In this slide, the second bullet point mentions technology and resources. In our example, technology is how many labor hours are required to produce each good. That's a very simplified version of technology. The resources are simple in terms of labor hours available for each country. In the next chapter, which we discuss supply and demand, you're going to begin to study how prices and quantities are determined. So in summary, interdependence and trade allow everyone to enjoy a greater quantity and a variety of goods and services. Comparative advantage means being able to produce a good at a lower opportunity cost, and absolute advantage means being able to produce a good with fewer inputs. Again, the key, when you hear comparative advantage, I want you to think the person who has the country, the nation, whatever that has a comparative advantage has a lower opportunity cost. Comparative advantage, opportunity cost. Absolute advantage, input costs. When people or countries specialize in goods in which they have a comparative advantage, the economic pie grows and trade can make everyone better off. Essentially, there's more of everything. And when there's more of everything, you have more selection at a lower price, and that's a really good thing for a society. Okay, this concludes the lecture recording video for Chapter 3, Interdependence and Gains from Trade. As always, let me know if you have any questions. Feel free to drop by, give me a call, or send me a message. Thanks so much. As an addendum to this lecture, I must correct myself. I attributed the one-armed economist quote to President Richard Nixon. I was only off by about 20 years. It was actually Harry Truman who famously asked to be sent a one-armed economist, having become tired of hearing his own economists say, on the one hand this, and on the other hand that. He wanted a one-armed economist. Anyway, my quest for perfection continues. Just wanted to make sure I corrected myself in that lecture. Thanks.